Okay, today we're going to talk about probability measures. Now, we've probably thought about this a little bit intuitively. Well, like, yeah, probability is a percentage or something, but we're going to define a formal way to explain what a probability measure really is. Okay, so a probability measure is a function on some sample space. We're going to call this function p. And p, where does that function go from? It goes from the sample space. We'll call that s, and it gives us an output in the real number. So this is like any negative or positive number. It could be a decimal, it could be a fraction, it could be a whole number. So makes sense, right? In a sample space, remember what a sample space is? Well, it's a list of none, 1, ... up to all possible outcomes of an experiment. Okay? So a probability measure maps an outcome in our experiment to a number on the real line. So if it's going to be a probability measure, what kind of things would we naturally want this function to satisfy? Well, it doesn't really make sense to talk about negative probability, does it? No. So, one of the axioms of a probability measure is that P of E, where E is some event, is always greater than or equal to 0. Again, that's because probability doesn't make sense to have this be a negative number. So this is going to be our first thing about probability measures. Okay? What else needs to happen for this to make sense? Well, I know that the possibility that something in the sample space occurs, i.e. S, must equal 1, because either nothing happened or 1 up to all of the possible outcomes of the experiment must have happened. Just doesn't make sense any other way. Okay, and what else? I guess what else would be important to include in this, right? These two things definitely make sense, kind of when we're logically thinking about, hey, what do we want probability to mean? And this third thing is that